Hello everybody and welcome to my video. I'm going to be talking about this paper I wrote and a framework for simulating asteroid impacts and their effects by Utkar Sharma in September 2025. I actually wrote this towards the end of September, so more towards the beginning of October, I think. And I've polished it in October, so basically I finished writing it in October. And there's a couple of reasons why I wrote this paper in the first place. First things first, I think that writing papers like this helps me cognitively understand the subject better because writing research papers allows you to actually do research, and in the process you have to come up with problems of your own and solve them yourself, and you have to make it and you have to write it in a way that other people can understand. I think this all goes back to the Einstein quote where he said, if you can't teach it to a toddler, you don't really understand it yourself, and that's why I think I write papers like this. So, a framework for simulating asteroid impacts and their effects. So, these are the contents, abstract data sets to consider, and there's a reason. Okay, so I went over the first reason why I wrote this. Let's go to the second reason. So, the second reason is my friend invited me to this hackathon recently, and this hackathon had a couple of challenges, but it was by NASA itself. So NASA Space Apps challenges, if you can see it in the browser tabs. And so basically, it was about simulating asteroid impacts and seeing the destructive capabilities. And along with that, we had to make it actually simulated. Like, we can't just throw an asteroid on Earth. And we had a team of 6 people, and my job in the team was to actually simulate the asteroid. And if you want to know how it turned out, I'll show it at the end of the video. So a framework of, I'll also be explaining the code I've written over here. And this is three. I mean, this doesn't really need to be three files. I just think it helps with getting the stuff right. And I don't really have much in style of CSS. I only have in base and script. So let's start. A framework for simulating asteroid impacts and their effects. Contents, abstract, data sets to consider. Yeah. Okay, abstract. Asteroid impacts pose dangerous threats to our planet with potential catastrophic consequences. This paper presents a simplified framework for simulating asteroid impacts using publicly available datasets. Orbital and approach data are obtained from NASA's CNU API, while seismic, tsunami, and elevation data are sourced from publicly available USGS datasets. To simulate the asteroid's motion, Newton's laws of gravitation are applied, and an RK4 function is employed to approximate its trajectory towards Earth. On impact, the destructive capabilities are measured on a TNT scale along with the seismic and tsunami effects, which may be calculated or retrieved from relevant datasets. Finally, asteroid deflection strategies are discussed, briefly touching on NASA's dark missions to deflate the Dimorphos from its orbit. This paper provides a framework to create an open-source simulation of asteroid impacts and mitigation. I think instead of this to consider and everything else, we need to firstly, this is the main part, this is the main heart of the whole PDF. So building the asteroid impact simulation, and this, we have to go with an algorithm for it. So what I'm doing here is basically, okay, so we have to initialize parameters. So we have to take an asteroid and we have to basically get an Earth, then an asteroid. We have to set the mass of an asteroid and its radius. We have to set its initial position and its velocity. That's self-explanatory. And we have to set Tmax to a certain value, but this isn't really necessary. I didn't really keep this in my own simulation. So while T is greater than Tmax and R is greater than R Earth. So this line says that while the position of the asteroid is greater than the radius of the Earth, which also means, which translates to, has the asteroid impacted the Earth or not? If it has, stop the simulation. If it's not, then you don't. You continue. And there's, I apply RK4 to update position velocity. Now what is RK4? Let's say that, okay, let's go down here to understand RK4. So in physics, a lot of differential equations we can't really solve for positions themselves. Now I don't really know if I can solve R's position. I mean, I don't really know if I can solve this differential equation. Now, From Newton's gravitational law, we know that gravity is basically like the mass of the gravitational force between two planets or two objects is the mass of them, the product of their masses divided by the the square of the distance between them and multiplied to a gravitational constant. In a vector form, you have to add a unit vector to it, and that's what I did here. But this is pretty explanatory. This is basically just this is the mass of Earth, and this is the r cube, and this is r, so it will cancel to m squared. This is the acceleration due to gravitational, and this is a differential equation, which I need to solve two times. So basically, I'm trying to get velocity out of the acceleration, and I'm trying to get the position out of that velocity. And so to do that, I will have to implement various differential equation solving techniques. I thought of using Euler's method, but that didn't really work out because Euler's method gets really inaccurate after a certain point. And what I landed on was an RK4 function. Now RK4 is basically, it's like Euler's function. So basically you take this. So you take the first radius, then you take the second after from K1. I can't really explain RK4 here because it's a really nice topic. I will link a video down below if you want to check out more information about RK4 from a channel that focuses on astrodynamics itself. I'm not really an expert in astrodynamics. I'm just a dude doing a hackathon project, but this basically gives me an approximate estimate of the position of the asteroid. And so this is the main physics. This is the main importance of my whole code. This is, I've written even in code right now. And I've basically touched on what an RK4 is. If you want to study this, you can do this now. State vector is basically the radius, the position of the asteroid in the vector, and we just solve for this, yeah. And I talk about RK4 over here. So this is the main part of the asteroid impact simulation. This is just how I can calculate energy. If you want, I will link this PDF down below, but this isn't really that important. So let's see the code now. So this is the code. Fair bit of warning, I did use a little bit of AI to debug this program, but most of it was written by me. Because a lot of the times I would write a code difference that looked fine to me, but it would look black, and I don't really think I can really get that anywhere around in AI. Feel free to let me know if that was a mistake of my part, but I think this is. So, quick rundown. We'll keep the general constants, we'll keep the Earth constants, asteroid constants, the initial velocity, initial position, and we'll paste that to an HTML file. Scene boy, const camera, yada. We set up the scene in Trajectories. So this is the scene, this is the camera, this is the position, and then we keep a renderer and render it, and append child rendered on element, and yada. I think I kept the scene. The main scene is down over here, I think. Yep, render scene camera. This is the main part. So everything that's in it will be run on this scene. So you can see here scene.add, and I think scene is like a sort of array or a list where you can add elements to it and give them their own properties. So more like a tensor, if I'm using that right, obviously. So you get this, and this isn't really important. This is just I'm loading Earth, I'm giving it light, I'm keeping an asteroid, I'm keeping a trail set up, and but here is the main part. Okay, this is the main AI part I use. I couldn't really create stars. I wanted to keep a galaxy background, but I thought I don't really know how to get that 360-degree image, and I know that I probably think that Three.js has a function that does that, but I didn't really know what I was thinking during it. But but ChatGPT helped me through this at least. But this was the real kicker. So acceleration, and you can see I translated the algorithm. So this is the acceleration function, and from this acceleration function, I'm running a RK4 function. And from that, I'm running BAM and then animate. I'm animating it, and so this is the whole code. And I think it's pretty self-explanatory once you can get it. This is basically, I'm just showing vel map, and this means that I'm storing each function as like x, y, and z coordinates, and like x, y, and z units or bases. And that's pretty much it. And look at this. This is the main thing. So I calculate the distance, and if the distance is less than the radius of the Earth plus the radius of asteroid, then I click that impact time, and then I go over here and say norm lat long and convert it into latitude and longitude, because it is important in the overall hackathon. This is not the whole hackathon. We have to create so much more. Now we have to make the asteroid disappear after it collides the Earth, and this is if the distance is less than radius of the Earth. I think what I need to do is, now that we look at this code, is get rid of the equals to. But we will see what it does. So controller update render.render and bada bing bada boom, and that's the whole code. And I did this from 3JS, and it's pretty. So I have two textures. So this is the Earth texture, and this is the bam.png that my dad told me to use, but I don't really know what I'm supposed to do with it. It looks more comedic than anything else. Maybe I'll keep it for the funs, but I did actually keep it, I think. Yeah, I did really keep it. So it's over here, sprite. Yep, I added this sprite, and it loaded, but I'm having a bit of trouble with it, so I think I'm just gonna have to forego this part. So that means I'll have to go over here and set this. So we'll see my impact, asteroid impact now. Look at this. So that went pretty fast, so I think I'll go over here and change the DT from 500 to 50, I think. I'll reduce it by 90%. As you can see, the asteroid is pretty far away, and it's curving because of how or it accelerates its body. I can make it orbit, so to do that I think I'll do 100. I will set this time DT to 100, and the velocity will be the same, so maybe it will work now. So it is trying to curve, and we'll see if it curves or it impacts Earth. I think it'll orbit, yep. So as you can see, it creates a pretty eccentric orbit, and that's because of where it's positioned. And this is a two-body system I created. The stars are just there for effect. They don't really have it. Actually, look at this pixel that I've got over here. That this is meant to be a star, but this shouldn't really be here. I tried to fix this, but then the stars all disappeared, and I don't really know if solution to it. Maybe I'll add somebody else. But as you can see, the asteroid isn't impacting Earth at this point, and that means that I've set up the position and function so that it barely grazes over it. And it also confirms how Kepler's laws that all orbits are ellipses. And that's pretty neat. And I can probably calculate the eccentricity of this orbit, and it's, this is too slow. I can probably calculate the eccentricity of this orbit, and also its, I can calculate it like mean, what do you call it, a node, or the argument of periapsis or something like that. I read about it a little bit, but I really got bored of it because I couldn't understand half of it, and I don't think how it could be useful in this program at least. And yep, this is basically my asteroid project. Thank you very much for watching. My name is Basama. I'll probably be making some more simulations or math related videos in the future. Until next time, thank you very much. Bye bye.